Hi class, today we'll be discussing section 6.3, square root functions. To start off with, a square root function is a function that contains the square root of a variable expression. The domain of a square root function is those values for which the radicand, that means what's under here, is actually greater than or equal to 0. So in the example, graph y equals the square root of 3x minus 2, state its domain and range. So since the radicand cannot be negative, the domain of the function is found by just looking at what's in the radicand, which is 3x minus 2, set that greater than or equal to 0, and then solve for x. That is your domain. If you plug it in here, since it was set greater than or equal to x, if you plug that value back in here, it's going to give you x. So the range is going to be greater than or equal, or it's going to give you, if you plug the value back in, it's going to give you 0, which is the range of the domain, that it's greater than or equal to 0. So in this first example, they've started with the starting point of the domain, which was 2/3, and we know that y is 0, so you kind of just have to approximate where that is. Then they plugged in a 1, so you can use your calculator to do these. Or just 3 minus 1 is 3 times 1 is 3, minus 2 would be 1, the square root of 1 would be 1. So we have a point at 1, 1. And then if you plugged in a 2, that would give you 6 minus 2 is 4, square root of 4 is 2. So we'd have a point at 2, 2. Now when you plug in a 3, 3 times 3 is 9, minus 2 is 7, so the y value is the square root of 7. So you'd have to find the decimal approximation for that to put it, to figure out where it went on the graph. But you can see that it's somewhere between 2 and 3, closer to 3. So then you're just going to take the points that you have graphed and connect them, and then just draw an arched line. And I like to call the square root function the eyebrow function, because to me it looks like the shape of an eyebrow. Okay, so when you draw it, it's going to be arched. It's going to have an arch to it. All right, so let's try a few examples together. So to find our domain, which will be our first step, we're going to take the radicand, which is 2x, set that greater than or equal to 0. So we divide by 2, and that would tell us that x is greater than or equal to 0. Now to find the y, take your square root of 2 times 0, which I'm getting the 0 from right here, and that equals 0. So your range would be y is greater than or equal to 0. I guess I should have written them right here. X greater than or equal to 0, y greater than or equal to 0. So when we plugged in a 0 for x, that would look like this. That's what you could put in your calculator. You get a 0 for y. So we have a point at 0, 0. Then let's say we plug in a 2. And I'm just doing that because if I take the square root of, if I put a 2 in here, square root of 2 times 2 would be square root of 4, which is 2. So we have a point at 2, 2. Now, the next number I think I'll put in, let's see, I can't get the square root of 9 from multiplying by 2. I'm going to put an 8 in. Now, you do not have to, when you do these on your own, think about perfect squares, you can plug in any value you want, just get the decimal approximation and try to get that as close as you can on the graph. So I said an 8, so plug in an 8. We'll have the square root of 2 times 8, which would be the square root of 16, which is 4. So I'm going to go out 8, 1, 2, 3, 4, 5, 6, 7, 8, and I'm going to go up 4. 1, 2, 3, 4. So see how it makes an arch? And then you can just put an arrow at the end of that arch. Okay, for the second one, we're just going to take what's under the radicand to find the domain. So that's x minus 3. We set that greater than or equal to 0, and we solve it for x. So we can see that x is greater than or equal to 3. So we put x greater than equal to 3. Then you're going to take your whole function. This time there's a 2 out in front. So you're going to plug in, 2 times the square root of 3 minus 3. So that would be 2 times the square root of 0, which is 0. Y then is greater than or equal to 0. And I should have mentioned that in this one, if you can see if x is greater than or equal to 0 and y is greater than or equal to 0, then you're not going past this point of a 0 of 0. This time we're not going to go past, and I say past, I mean to one side. You're not going to go that way. We're only going greater than. So this time we're going to go greater than the point at 3, 0. So you plug in the 3 here. 2 times 3 minus 3 gave us 0. So we have a point 1, 2, 3, 0. Okay, then I plugged in a 4 because it gives me a whole number. 2 times the square root of 4 minus 1, or 4 minus 3, excuse me, which would be a 1. The square root of 1 is 1. 2 times 1 is 2. So I'm going to go to 4, 2. And then I plugged in a 6. So you could plug in a 5 if you wanted to. But when I plugged in a 6, 2 times the square root of 6 minus 3, that gave me approximately 3.5. So that was easy for me to graph. So I'm going to go to 6, and I'm going to go up to 3.5. So here's the arch on this one. Stick an arrow at the end of it. Okay, let's try a couple more examples. So we take what the radicand is, or what's under the square root, set it equal, greater than or equal to 0, and solve it for x. So the first thing we would do would be to subtract 5 from both sides. So 2x would be greater than or equal to negative 5. Then we're going to divide by 2. So x is going to be greater than or equal to negative 5 halves. Or you could say x is greater than or equal to negative 2.5 when you put it on the graph. So if we plug in a negative 5 halves into this square root, 2 times negative 5 halves plus 5, these are going to cancel. We'll have negative 5 plus 5 would be 0. The square root of 0 is 0. So y is greater than or equal to 0. So when x is 5 halves, or if you want to put 2.5, does not look like a 2. Well, what's going on with my pen? 2.5. Something's strange going on with my pen. That's a 2.5. And you would do the square root 2 times the 2.5 plus 5, or that was, I'm sorry, that's negative. It's supposed to be negative 2.5. So squeeze in a negative in here if you can. We already know the answer to that though, it's 0. So we're going to go to negative 2.5 and 0 and plot a point. Okay, the next number I put in was a 2. Again, doesn't matter. Any number that's greater than the negative 5 halves, you can use as your next point. So you could plug in a negative 2 or any point on here. I just plugged in a 2 because 2 times 2 plus 5 is 9, and the square root of 9 is 3. So I knew I'd have a point at 2, 1, 2, 3. And then the third point I plugged in, or the third number I plugged in was a 5, I think. Yeah. The square root of 2 times 5 plus 5. The square root of 15 is approximately 3 point, I can't read my writing if that's a 3.8. Yeah, I think it's a 3.8. So go to 5. 1, 2, 3, 4, 5. Go almost up to the 4. That'll be our 3.8. Draw your arch and your arrow at the end. Okay, and the last one, take what's underneath the square root to find the domain. So I take x plus 7, set it greater than or equal to 0, subtract 7 from both sides. X will be greater than or equal to negative 7, so that's our domain. Now, when we figure out for y, we use the whole function. So we have negative 7 plus 7 minus 4. Well, this would give us the square root of 0 minus 4, which is negative 4. So y is greater than or equal to negative 4. So negative 7, again, we just plugged it in here. And then you can use your calculator. Gave us negative 4. So negative 1, 2, 3, 4, 5, 6, 7. Negative 1, 2, 3, 4. Then I plugged in a negative 6. Again, any number to the right of this negative 7 you can use for x. So negative 6 gave me negative 6 plus 7 minus 4. Square root of 1 is 1. 1 minus 4 would be negative 3. So we have negative 6, negative 1, 2, 3. And then I plugged in a negative 3. Just again, I'm using things that if they can give me a whole number because they're perfect square, that's what I'm using. So next I plugged in a negative 3 because the square root of negative 3 plus 7 is equivalent to having the square root of 4, which is 2. 2 minus 4 is negative 2. So negative 3, 1, 2, 3, negative 2. And then you're going to just draw an arrow at the end. Okay, so again, when you do these on the practice, it doesn't matter what numbers you use, as long as they're to the right of where your domain starts, okay? To the right of that. To the right of negative 7. To the right of negative 2.5. Any values for x you want along here, you can use. All right, I hope y'all have a good day, and I'll see you next time.